Okay, good evening, guys. Today there is no student, might be because of rescheduling of the lecture. So, anyways, I will try to explain you guys all these questions. You guys can watch it later on the YouTube as well. So, the first question is identify the correct statement regarding the carbohydrates. So we have to find out the correct statements about the carbohydrate. So first statement is they serve as the energy storage, fuel, metabolic intermediates. So is this statement correct? So as we have seen that in case of the plant, carbohydrate can be used as energy storage such as starch, and in case of animal also there is a carbohydrate called glycogen which is acting as a energy storage, which is used as used for energy storage. So this statement is correct actually. And second statement, they are majorly found as part of the structural framework in RNA but not in DNA. So carbohydrate, they are saying that it is found in RNA but not in DNA. So this statement is wrong because in case of the RNA there is sugar, which is which sugar is there in RNA? It is ribonucleo. It is this pentose sugar. Pentose sugar is there in two in case of RNA, while in case of DNA, deoxyribose sugar is there. So in case of RNA, this pentose sugar, ribose sugar is there, while in case of DNA, there is deoxyribose sugar. So next statement is they comprise the structural element of the cell wall of bacteria. Yes, the cell wall of bacteria is made up of the peptidoglycan, which is also a carbohydrate. So this statement is also right. Hi, where are students today? Hello, Arun. Can you hear me? Hello, am I audible? Arun Kumar, please unmute yourself. Can you hear me? Hello. Yes, yes. I will give you, but you first unmute yourself. Let's complete the today's lecture. Then we will discuss. You tell me what is the problem. Tell me here only. Please unmute yourself. Don't use chat box. We will solve the assignment. Have you solved these questions? Hello. Okay. So in this question, they are asking regarding the carbohydrates. Correct statements regarding the carbohydrate. So first statement is they serve as the energy storage, fuel, and metabolic intermediate. So this statement is correct. Yes, we know that starch is the energy storage, uh, used as energy storage for in case of plants, while in case of animal there is glycogen. And in second statement, it is saying that they are majorly found as a part of the structural framework in RNA, but not in DNA. So this statement is wrong because in case of RNA, there is ribonucleoprotein, while sorry, this sugar is there, ribose sugar is there in case of RNA, while in case of DNA, there is deoxyribose sugar is also there. So it is saying that in case of DNA, it is absent. So that's why this statement is wrong. While in case of third statement, it is saying that they comprises the structural element of the cell wall of bacteria. Yes, this statement is also right because bacterial cell wall is made up of peptidoglycan, which is also a carbohydrate. So they are found in the exoskeleton of arthropods. Yes, this statement is also correct because exoskeleton is made up of chitin. So according to this, only second statement is wrong. So this option can't be correct. So option A is correct for this question. Yes. Uh, as I discussed that for energy storage, in case of plant, starch is used. Like starch is stored in potatoes, roots, while in case of animal, there is glycogen. And this chitin, exoskeleton of arthropods, it is made up of chitin, and this is also a carbohydrate. Okay, let's solve the second question. So we have to match it. So in column 1 they have given us some carbohydrate, and in column 2 they are giving some characteristic about this, like they are asking what is mannose. So we should know the structure of mannose first, then only we can tell what is mannose. They mannose is actually the C2 epimer of glucose. So if we know the structure of mannose as well as glucose, then only we can tell that this is the C2 epimer or C4 epimer. Well, C4 epimer of glucose is galactose, and fructose is aldopentose. So according to this, option C is correct for this question. So what are epimers? So epimers are the uh, compounds where only there will be the difference at single carbon. Like this is the structure of glucose. Always we used to label, we used to start numbering from this functional group. This is one. This is second carbon, this is third, this one is fourth, this is 5, and this is 6 carbon. So this is glucose, D glucose. D glucose and L glucose we can find out from the last chiral carbon. So this is the last chiral carbon where the OH functional group is attached towards the right side. So it is D. If it is attached to the left side, then it is L. So this is the D glucose and this is the structure of D mannose. So what is the difference between these two structures? Only this carbon. So this OH is towards the right side, left side in this case, and right side in this case. So there is a difference at single carbon only. That's why they are the second carbon. So this is first carbon, this is second carbon. So glucose and mannose are the C2 epimer of each other. While galactose, in case of the galactose, so what is the difference between glucose and galactose structure? So here we can see, so this is first carbon, this is second carbon, this is third carbon, this is fourth carbon. So at fourth carbon, in case of glucose, at the right side there is OH, while in case of the galactose, this OH is at towards the left side. So this is the galactose is the C4 epimer of glucose. So epimer means there will be the difference only at single carbon. Okay. So we discussed previously what is the meaning of this alpha and what is the meaning of beta. So if this OH group at the first carbon, if it is attached downward this side, then we call it as alpha. And if it is attached towards the upper side, then we can call it as beta. So all these are nomenclatures. So this is the alpha D glucose and this is beta D glucose. And this is mannose, alpha D mannose, this is beta D mannose. So in case of mannose, what was the difference? So mannose was the C2 epimer. So at the carbon number 2, so this is the carbon number 1 and this is carbon number 2. So this is carbon number 1, this is carbon number 2. Here we can see that OH is downward and in case of mannose, OH is upward. So these two things are C2 epimer of each other. Okay, so next one is galactose. So galactose and glucose are the C4 epimer of each other. So here also we can see this is the first carbon, this is second carbon, this is carbon number 3, this is carbon number 4, and it is 5, 6. So in case of galactose also we will do the numbering likewise 1, 2, 3, 4, 5, 6. So at the carbon number 4, here we can see that in case of the glucose, this OH is towards the downward, and in case of the galactose, this OH is towards the upward. So both of these glucose and galactose are the C4 epimer of each other. Okay, so what is fructose? Fructose is aldose, aldopentose. So 5 carbons are there, so it is aldopentose. Okay. So this is the question number 3 and this will be based on this schematic as given here. So what is it asking? Based on the structure A, B, C, answer the question 2, 3 and 4. So question 3 is asking what is A, B and C. So A is, so we can see that this is good. This is the structure of glucose. We should know the structure of glucose. So in case of glucose, so this is OH group here and then H, then OH, OH. So can we say any difference between A and B? So in case of A, this at carbon number 2, there is a difference. Carbon number 2, OH is towards the left side, while in case of glucose, towards the right side. So what is this? C2 epimer. So what this is the C2 A is the C2 epimer of B, right? And what about the C? C is differing at 1, 2, 3, 4. So C is the C4 epimer of B. So as we discussed in the previous slide also, that this is the if it is C4 epimer is the galactose, and C2 epimer is the mannose, and this one is the B structure is the glucose. Okay. So this question number 4 is also based on this schematics. So same here also they are asking about the epimer. Again, this is the B is the structure of glucose, and we can see that it is the C2 epimer because it is differing at the carbon number 2, and this is the C4 epimer because it is differing at the carbon number 4. So A is the C2 epimer of B while C is the C4 epimer of B. So statement A and B are correct. First and second is correct. So that's why option A is correct for this. Okay. Arun, can you hear me? Please say yes, no, because I don't know whether I'm able to
Yes,
record
ma'am.
it.
Yes.
So why you are muting yourself?
I'm traveling inside.
Huh?
During traveling, ma'am.
You are traveling?
During travel.
Okay. Don't worry, it's okay. Let's solve the question. Have you solved this? Have you solved this question number 5? Tell me what is the answer for this? Don't write, reply. Okay, so how we used to number it? We used to label it from here, this carbon. So this is carbon number 1, this is 2, this is 3, this is 4, and this is 5, and this one is 6. Similarly, this is the carbon number 1, 2, 3, 4, 5, 6. So as I told you that if at the carbon number 1, if OH is towards the downside, then we call it as alpha. And if it is upper side, then we can call it beta. So in this case, here is the OH. So this is the O. This is the O coming from this OH. So this is beta. This is beta. And this linkage is between carbon number 1 of this monomer and carbon number 4 of this monomer. So that's why this is beta 1,4. Beta 1,4. So glycosidic bond. So option D is correct for this. Okay. So this is the question number 6. Here we have to match this. So D ribose sugar, as I told you before, that ribose sugar is present in RNA. So option fifth is A. So fifth is A, so we can cut D and A. These from these two options we have to choose now. So can we guess any other? Simplest sugar. So simplest sugar is the glyceraldehyde. So this is three carbon sugar only. So this is the simplest sugar, glyceraldehyde. So A is E. So now C option is also gone. So option B is correct for this. And fructose is, what is fructose? Sweetest sugar. What about galactose? It is the part of milk. So option B is correct. So this is the glyceraldehyde, and as I told you that this is the 3 carbon sugar only, and it is the simplest sugar. This is the structure of glyceraldehyde. And this is the structure of fructose. It is 5 carbon containing sugar. And this is ribose. We have to remember the structure. So question number 7. In aqueous solution, D glucose exists as either D glucose or beta alpha D glucose or beta D glucose. So this occur because, so they are asking why it is either alpha or beta. Alpha means if at the carbon number 1 OH is attached downward, and in case of beta it will be upward. So this is alpha and this is beta. So why it is happening? This is happening because aldehyde react with alcohol to form hemiacetal. This will form hemiacetal, it will not form complete acetal. So option A is correct. So if any aldehyde is reacting with any alcohol, then hemiacetal will form, and this is the structure. Okay, question number 8. The different stereoisomers formed due to the cyclization at the aldehyde or ketone carbon are called. So what is this asking? The different stereoisomers formed due to the cyclization at the aldehyde or ketone carbon are called. They are known as anomers. At aldehyde, so we can see this is the uh, chain structure, and it we can cyclize it also. So this cyclization is happening at this aldehyde or ketone carbon. So after cyclization, we are calling it as anomers. They are known as anomers of each other. So, what is the difference between anomers and epimers? As epimers, I told you before that there will be two similar kind of structure. There will be difference at the single carbon. At single carbon, there will be difference in the alignment or arrangement. But in case of anomer, so the anomer is a type of stereoisomer differing in the configuration at the acetal hemiacetal carbon. It is example, alpha D fructofuranose and beta D fructofuranose. And the example of epimer we have seen that glucose and galactose, glucose and mannose. Okay, so this is the question number 9. So in this question, which of the following is an anomeric pair? So anomeric pair is alpha D glucose or mannose. We discussed before that glucose and mannose are the epimer, not anomer. So glucose, alpha D glucose, beta D glucose. So these are two anomer because they are differing at the carbon number 1. Differ means arrangement is functional group. At alpha, this is the beta if it is upward, and this is alpha if it is downward. So this alpha beta are known as to be anomer of each other. Rest of are the example of epimer, not anomer. So option number C is correct for this. Okay. So this is the question number 10. So in this, they are asking that starch and glycogen both are polymer of. So as we know that starch and glycogen. Starch is the storage form present in the plants, while this is also the storage form of carbohydrate present in animal. So this is in plants and this is in animals. So both of these are polymers. Polymers means it contain the multiple unit of a single monomer. These are the monomer and they are joining together to form a polymer. So these monomer, they are asking what is this monomer in case of starch and glycogen. So both in both the cases it is same starch and glycogen. There is glucose. So glucose, alpha D glucose is the polymer of monomer of starch and glycogen. So option C is correct. This is the structure of alpha D glucose. As I told you, this is alpha because OH is downward. So both the starch and glycogen are made up of this monomeric units. Many alpha D glucose will be attached together like this. So this is the structure of glycogen. Alpha 1,4 glycosidic bond will be there. First carbon of one monomeric unit will be attached to the fourth carbon of the next monomeric unit. And there will be the branching also. And in branching, there will be the alpha 1,6 glycosidic linkage. Okay. So this is the question number 11. So they are asking about this conformation. So which conformation is uh, most stable compared to other? So more stable configuration is boat or chair. So this is the boat and this is the chair, and this is stable compared to this because there will be less steric hindrance. So less steric hindrance means if let's say this is one element and this is another element or atom, so it is having, let's say this is one element and the, x and y is attached to this carbon. So there is another example where there is x, y, and z, this side and this side as well. So there is one z, there is one x, so there is one y. So there are so many electrons attached to all these, and they are electrons are not stable; they are revolving. So there will be hindrance, more steric hindrance come in this case compared to this one. So in a similar way, this is more stable because there is less steric crowding. Okay, this is the question number 12. So here they are asking that carbohydrates that are optically active have the ability to rotate the plane of polarized light. Light rotate in the clockwise direction is generally represented by the symbol. So they are asking, so they represent it by plus. If it is clockwise, it is plus, and if it is anti-clockwise, then it is minus. So option C is correct. While DL is something different. If like any functional group is attached towards the right side, they used to call it as D. And if any functional group is attached towards the left side, then they used to call it L. So this is the DL system correspond to the configuration of the molecule, spatial arrangement of its atom around the chiral center. So, let's say this is the chiral carbon in case of glucose, and OH is towards the right side. Then it is D. While the optical activity uh, to rotate the plane polarized light in a clockwise manner is denoted by plus, and in anti-clockwise manner it is denoted by minus. Okay. So in question number 13, it is asking that the main component of the plant cell wall. This is the very basic question of 10th, ninth class. Everybody knows that plant cells are made up of cellulose. Plant cells are made up of cellulose, and cellulose is also a polymer or carbohydrate. While glycogen, as I told you, that this is this energy storage component of animal, and peptidoglycan, this is the composition of this is the bacterial cell wall made up of peptidoglycan. And what is lignin then? So lignin is aromatic product of pulp and paper industry, and after cellulose it is the second most abundant biopolymer on the earth. Okay. Arun, why students are absent today?
Ma'am, going on to another class, ma'am.
That Mohan sir, right?
Yeah, yes, ma'am.
Okay.
Ma'am, I want your contact number for any clarification.
Yes, I'm writing my email address here.
Here, ma'am.
Here I'm typing my email address. You can convey anything if you want. So we have two more classes also. Have you solved all the questions, all the problems? When is your exam?
Ma'am, I didn't apply to the examination.
Okay, you haven't applied for exam. Where you are from? Which insti-
Tamil
which
Nadu,
inst- which institute?
Varidasan University,
Okay.
Tiruchirappalli.
So do you understand today's class?
Yeah, yes, ma'am.
Okay. So have you solved this question? So this question is basically based on Felling's reagent. So in Felling's reagent, this any aldehyde, if we are reacting with copper, so what will happen?
Option
It will
C,
option not C. It is Felling's reagent. It is Felling's reaction. Admin degradation is something else, not related to this. So this glucose is getting converted to gluconate. Glucose is getting converted into gluconate. This is the carboxylic group, na, COOH, and this is Felling's reagent. This copper. So option D is correct for this. So what is happening? This this copper copper plus 2 is getting converted to the copper plus 1. That means it is accepting the electron. It is getting reduced, and there is the oxidation of this glucose. So this glucose is getting oxidized to uh, gluconate or gluconic acid, while this copper is getting reduced here. Okay, so in question 15, what is it asking? That A is a dash form of glucose found in C. So how can we complete this? So starch is found in plants and glycogen is found in animal. So in statement second, it is saying starch is found in animal. So this is wrong. This can't be. And in fourth one, this is saying that glycogen is found in plants. So this is also wrong. So we are left with two. Starch is the polymeric form present in plants. So this is correct. And glycogen is a polymeric form present in animal. So this is also correct. So option number statement 1 and 3 is correct, though that's why option D is correct for this question. There was one girl, she asked me to solve this question actually. This question is from assignment 7. Question number 13 from assignment 7. I don't know the name of that girl. So this question is directly depend on the formula actually. So the formula was delta mu is equals to RT ln. So here will be the final concentration divided by initial plus Z F is the Faraday's constant and delta V. So here we have to find this delta V. So all the values are given in the question. Delta mu is also given, that is minus 9,000. R is also given here. R value for R is 8.314. Multiply by this temperature is given in degrees Celsius. We have to take temperature always in Kelvin actually. So we have to add 273 here. 273
Option D was
plus
the correct answer.
option D नहीं आएगा. So it will be equals to 298 Kelvin. So T will become 298. Actually, the value for this ln 0.01, value for this is minus 4.6. Minus 4.6 plus, and there are value for this will be 2, and Faraday constant is given 96500. So delta V we can calculate from this. If we will reshuffle this complete equation, we will get this is going to be around 11,000 something. 11,000 plus 2 into 9600, 96500, multiply by delta V, and it is equals to 9,000 minus 9,000. So this 11,000 will be minus when it will go this side. So we will minus this 11,000, 9,000 from this 11,000. We will get approximately 2,000 something. And when we will divide it with the rest of the thing, we will get it around 12.4948 millivolt. So option number A will be the correct. Minus sign will not be there because this value is greater than this. Understand?
Yes, ma'am.
Have you solved this?
Yes, ma'am.
Okay, do you have any doubt? Without students, class is very boring.
Ma'am, I defined the bond. You will correct for me, ma'am.
Huh?
Chemical bond.
We discussed that in last class, na?
Ma'am, I defined that you will check right or wrong.
Sorry?
I defined the bond, ma'am.
Huh.
You will check right or wrong.
Okay, define it.
Uh, Union of atom of two or more elements, uh, mutual interaction was called chemical bonding, ma'am.
Hmm.
Or a bond was an electrical force of atom. That's all, ma'am. And the bond was classified into two types. One of the primary bondings, and another one is a secondary bonding.
Hmm.
The primary bonding was classified into three types. They were ionic
Yes.
bond or electrostatic bond,
Huh.
and covalent bond,
Huh.
and then metallic bond.
Huh.
The the secondary bond was classified into two types. They were van der Waals bond and hydrogen bond.
Hmm.
That's all.
Yes, yes.
It will be correct, no?
Yes, yes, it's correct. So, do you know what is hydrogen bond? If somebody,
Hydrogen,
if someone is
hy-
asking you how hydrogen bond will form, how will you define that?
CH4, ma'am. The example of a
CH,
CH4.
CH4? No. So, hydrogen bond is it is always formed between, there will be three elements, these most electronegative elements, phon, chlorine, oxygen, and nitrogen. So any one of them will get bond with the hydrogen. Then it will be known as hydrogen bonding. Like NH3, it is also hydrogen bonding. Water, in water also there is hydrogen bonding, right?
Ma'am,
Any of
and
these,
hydrogen peroxide.
yes, H2O2. This is hydrogen peroxide. There is also hydrogen and oxygen is there. So any one of these three elements is getting bound with the hydrogen, then we call it as hydrogen bonding, right?
Yes, ma'am. Yes.
Okay. Anything else? No one is there, then we can't do today's class. We have to close it.
Yes, ma'am. Yes.
I have recorded this lecture and I will upload it on the YouTube. You guys can watch it.
Yes,
You
yes,
guys,
ma'am.
you can tell your friends also to watch. If they have any doubt, they can contact me again.
In another one doubt, ma'am.
Yes.
In the cell pathway of glycolysis,
Huh.
at the fourth stage, uh,
Huh.
1,6 bis fructophosphate that was cleaved with the help of enzyme was phosphofructoisomerase. That was correct, ma'am.
There is the formation of isomer.
Yeah, cleaving in
So
two types.
that is
One is
that is that is
dihydroxy
not that is
acetone
not
phosphate
clear.
and glycerolide 3 phosphate. So
So that is not
used the
cleavage.
enzyme of phosphofructoisomerase. That was correct enzyme, ma'am. Or another enzyme was used in that particular place, ma'am.
No, that is correct.
In week 12 assignment, the question was wrongly optioned, ma'am. Why?
In assign
Week
which
12th
assignment?
assignment. Week 12th assignment. That
Week.
yes, ma'am. Week 12 assignment. The question was raised, but the enzyme was mismatched.
Okay,
The
I will check it.
another enzyme was another enzyme was optioned to here, but
Okay, I
that
will
was not
I
correct.
will check that. We will discuss that. We have discussed the assignment 10 today. We will discuss 11, 12 as well.
Week 12, 12th assignment. Week 12 assignment.
Yes, yes, we will discuss that also in the next class.
Yes, ma'am. But the
Maybe next to
enzyme was
next.
wrongly approached in the fourth stage of glycolysis pathway.
Okay, I will check that.
Yes, ma'am. That's all.
Essay, but why you are late today?
Yes, ma'am. Yes, ma'am. I was late.
You are so late. We have completed the assignment 10. Have you solved that?
Yes, ma'am. I have solved assignment 10. Let me check it, ma'am.
Okay, so do you have any doubt there?
No, ma'am.
Okay,
The assignment next to it, I think that is a little tough. It was
okay,
easier. Yes, ma'am.
okay. So do you have any confusion in epimer, anomer? There is nothing much. What is epimer?
Ma'am, these are isomers. Um, I am not sure about them more, but these are isomers, epimers, anomers.
Yes, these are isomer. What is the difference between? There are two terms. One in one question they have used anomer. In one question they said epimer. So can you guess the difference between these two terms? So
Ma'am, I think,
basically, this epimer is so wait. In case of epimer, there will be the difference at single chiral carbon, right? Can you
right,
see
ma'am.
this? Can you see this difference? So what is the difference? This is the difference in the arrangement of the
Or,
functional group. Yeah, this is OH is in this case this is right side. In this case this is left side. Rest of the structure are same. So if it is on left side, we call it as mannose. If it is on right side, we are calling it as glucose. So these two things are the epimer of each other, and we can call it. So we are numbering. We are starting this numbering from this functional group. So this is one carbon. This is two carbon. This is three, and likewise. So this carbon number two arrangement is different. So we can say that glucose and mannose are the C2 epimer of each other, right?
yes, ma'am.
C2 epimer. So in case of the galactose, so there is difference at the carbon number 4 here compared to glucose. So this galactose and glucose, they are the C4 epimer of each other,
Right, ma'am.
right? So another term was anomer.
Numbers.
So have you heard about alpha and beta glucose, beta D glucose, alpha D glucose,
Yes, ma'am. But I am
right?
not able to remind it.
Yes,
Yes, ma'am.
yes, I will tell you. Don't worry. So this is the glucose. This is the structure of glucose. So at the carbon number one, this is the carbon number one. If this functional group OH is towards the downside, then
Alpha.
we call it as alpha, and if it is upward, then we call it as beta. So this difference at the carbon number one, upward and downward of this OH group, then we call it as anomer,
Okay.
right?
Right.
Rest of the questions are simple. Only these two, three questions. Yes, this is the same question. This is also same question. And in this question, they are asking about the. They want to know whether you know the how to number it or not, how to label it. So this is the first carbon, right?
Yes, ma'am.
So can you tell me whether OH is downward or upward here?
OH is upward because H is
So
shown.
so is it alpha or beta?
Beta.
So this is beta, right? And in this monomer, can you tell me on which carbon it is attached? So this is the first carbon of this monomer. So first carbon of first monomer is attached to which carbon of second monomer?
First is attached to the second at 4.
4, right?
4 carbon,
So
yes, ma'am.
because this is beta, we will check the first one. So this is beta and arrangement is 1 4. So this is beta 1 4 glycosidic bond. So this bonding they were asking, right? These are the simple questions. Nothing much is there. So one more thing is there. So they want to know whether you know the difference between L and R, plus and minus. Sometime we are writing like plus D glucose,
Yes,
right?
ma'am.
So
Plus
what is the meaning of this? So
dextrorotatory.
what this
Plus represented.
levorotatory dextro,
Yes, ma'am.
huh? So this is the rotation of plane polarized light, right? If it is clockwise, then it is positive. If it is anti-clockwise, then it
Negative.
is negative. So what is this L and R then?
L and it represents the L and D, which we say D glucose and L glucose.
Yeah, it is the representation of the functional group attached, right? If it is attached towards the right side, then they call it D, and if it is attached towards the left side, they call it L, DL. Like all the amino acid are, whether they are L or D.
Most of them are L.
Yes, not most, all of them are L.
One is perhaps exception.
No, there is no exception.
Okay.
There is exception of achiral amino acid.
Okay, okay, ma'am.
What is that?
That will have different groups attached to
Huh,
it. Yes,
all
ma'am.
the amino acid are chiral except one. Do you know that exception?
Glycine.
No. Yes, glycine.
Okay.
H is two H are there, right?
Yes, ma'am.
One side NH3, and then another side is COH. Okay, so plant cells are made up of
Cellulose.
cellulose and chitin. Where is it
Chitin.
present?
Fungi.
Yes. Do you know the bacterial cell wall is made up of what?
Peptidoglycan.
Peptidoglycan. So what is lignin then?
Lignin is a plant derivative pigment. It is present in plants.
Yeah, it is present in plant, but this is not the pigment.
Okay, ma'am.
Okay, so have you heard about the Fellings reagent or Fellings reaction?
Yes, ma'am. Copper. It contains copper. It helps us in reducing reaction.
This is the reducing reaction. So what is reducing here? What is the reducing reagent?
Here,
Reduction
Yes,
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 ma'am.
for
So glucose is reduced into
into.
it is salt of the
No,
gluconate.
glucose is getting oxidized here, so it is
Okay.
converting into gluconate, है ना? COH. It is getting oxidized. This copper is getting reduced. Can you see this Cu2 plus is getting converted
Yes,
to
ma'am.
Cu plus, right?
Yes, ma'am.
So we are giving one electron to Cu2 plus. That's why it is converting into Cu plus, right? Okay. So can you tell me where we can find starch?
Starch is found in plants,
Yes, and glucose
in humans, animals.
in animals. So this is nothing, they were asking only this thing, where is, so starch is the polymer present in plant and glycogen is the polymer present in animal. Okay, so in last class one girl was asking about this question. Have you faced any problem while solving this question?
Yes, ma'am. I didn't solve it. It was present in
you
previous assignments.
you were not able to solve it?
Yes, ma'am. I
Okay,
didn't write it. Then I left it.
no, this is the simple formula based question, there is nothing much.
And then
This is the
there
formula,
is a potential difference between vitamin C and
right?
I haven't solved it.
You solved it.
No, ma'am.
So there is nothing, everything is given in the question. So delta mu is also given minus 9,000, and this is R. So maybe you guys, she might be doing some mistake. So this is the temperature given at Celsius. So this is the rule that we always use to take the Celsius temperature in Kelvin. So
Kelvin.
first we have to convert this temperature in Kelvin. So for converting any temperature from Celsius to Kelvin, we can add 273, right?
73 please.
So it will be now 298 Kelvin. Rest of the things is given. R is also given. We don't have to change it. And ln 10 divided by 10,000, its value will be minus 4.6. This is the natural log, and I think calculator will be there for this. It is minus 4.6. It will, when we will calculate this completely, it will come around minus 11,000. So this minus 11,000, when we will transfer it to this side, it will get converted to plus 11,000, approx 11,000. So then we can divide it with this 2 into 96500. So this is the Faraday's constant, and its value is given here. So the answer will come around 12.5 millivolt. Answer is coming, there is no problem. You guys can solve it again. So this is the equation on which it is based. If you face any problem, then I will solve it again.
Okay, ma'am.
Okay. So do you have any doubt?
Oh, thank you, ma'am.
Nobody joined today. I don't know why. Class is very boring without students.
And from last few classes, there are less number of students coming.
Ah. You had your dinner?
Yes, ma'am.
I
Just
don't
now.
had af- I don't had after iftar. I sit here.
Very tired.
Okay. So tell me if you have any doubt.
What was the chiral carbon?
Huh?
Chiral carbon.
Chiral carbon. So
Yeah.
uh, or, chiral carbon is the carbon actually if all the attached moieties are different. Like let's say this is the carbon, and one side hydrogen is attached, and the side there is any like fluorine, and the side chlorine, and the side bromine. So all the attached element, four attached elements are different. Then this will behave as a chiral carbon.
Oh, okay, ma'am.
Okay, guys, then we will meet in the next class on Sunday. I will not change the timing. Maybe next to next will be the last class for us. Thank
Okay,
you
ma'am.
so much.
Thank you, ma'am.
Thank you so much. And if you
Thank you,
have
ma'am.
any doubt about the biochemistry, you guys can mail me so that we can discuss it. Okay. Thank you.
Yes.
Ma'am, what's your
Thank you so much.
email ID?
Okay, I'm writing here. I'm typing it. Shiba21 at the rate iserb
Okay.
dot ac dot in. Okay, guys. Thank you.
Thank you, ma'am.
Thank you so much.